In 2024 alone, the price of antimony skyrocketed from $10,000 to over $25,000 per ton. This wasn't due to natural scarcity, but a calculated move by China. As trade tensions escalate, China is wielding its resource dominance as a weapon. The US now faces a critical shortage of materials needed for everything from solar panels to guided missiles. The US-China trade war has been brewing for years, but recent events have pushed tensions to new heights. In 2018, President Trump initiated a series of tariffs on Chinese goods, citing unfair trade practices and intellectual property theft. These tariffs covered a wide range of products, from electronics to agricultural goods, and amounted to billions of dollars. China responded with its own tariffs on US products, leading to a tit-for-tat escalation. The situation intensified when Trump announced plans for additional tariffs on nearly all remaining Chinese imports. This move threatened to disrupt global supply chains and increase costs for US consumers and businesses. In a surprising countermove, China announced export restrictions on critical minerals. This decision sent shockwaves through global markets and highlighted China's dominance in the production of these essential resources. The minerals affected by the restrictions include gallium, germanium, and antimony. These minerals play a crucial role in modern technology and defense systems. Gallium is used in semiconductors, LED lights, and solar panels. Germanium is essential for fiber optic systems and infrared optics. Antimony is a key component in fire retardants and batteries. Their importance extends beyond consumer electronics to critical defense applications, including missile guidance systems and night vision technology. The announcement of China's export restrictions caused immediate market reactions. Prices for these minerals surged, with some seeing increases of over 100% in a matter of days. Stock prices of companies reliant on these materials plummeted, and investors scrambled to assess the potential impact on various industries. US manufacturing faces significant challenges as a result of these restrictions. Many companies rely on a steady supply of these minerals for their production processes. The automotive industry, for example, uses gallium in electric vehicle components. The tech sector depends on germanium for various applications. Without access to these materials, production lines could face slowdowns or even shutdowns. The immediate impact on US manufacturing is likely to be severe. Companies may need to quickly find alternative suppliers or redesign their products to use different materials. This process can be time-consuming and expensive, potentially leading to increased costs for consumers and decreased competitiveness for US businesses in the global market. As the situation unfolds, it's becoming clear that China's position in the global supply chain for critical minerals gives it significant leverage in trade negotiations. The country's dominance in rare earth production and processing has been a concern for Western nations for years, but these recent events have brought the issue into sharp focus. China's strategic advantage in this sector is the result of decades of investment and development. The country recognized the importance of these resources early on and has consistently worked to strengthen its position. This foresight has now placed China in a powerful position as trade tensions escalate. The US and its allies are now faced with the challenge of securing alternative supply chains for these critical minerals. However, establishing new sources of production and processing capabilities is a complex and time-consuming process. It requires significant investment and may have environmental implications that need to be carefully considered. As we examine China's strategic position in the global rare earth mineral market, it becomes clear that the country's influence extends far beyond simple trade dynamics. The control of these resources has significant implications for technological development, economic growth, and national security. Rare earth minerals play a crucial role in modern technology, and China's dominance in this sector has become a major concern for many countries. China currently produces about 80% of the world's rare earth minerals, giving it a significant advantage in the global market. This dominance extends to critical minerals like gallium, germanium, and antimony, where China's market share is even higher, reaching up to 95% for some elements. The challenges in establishing alternative supply chains for these minerals are substantial. Other countries have struggled to compete with China's well-established infrastructure and expertise in rare earth mining and processing. The industrial capabilities required to extract and refine these minerals are complex and expensive to develop. China has spent decades building its rare earth industry, creating a formidable lead that is difficult for other nations to overcome. Several countries have attempted to establish their own rare earth mining operations, but most have failed to gain significant traction. These failures are largely due to China's competitive advantages in processing technologies and cost efficiencies. For example, the Mountain Pass mine in California, once the world's largest rare earth producer, struggled to compete with Chinese prices and eventually shut down in 2002. Although it reopened in 2012, it has faced ongoing challenges in matching China's production capabilities. China's investments in rare earth processing capabilities have been substantial and strategic. The country has developed advanced technologies for extracting and refining rare earth elements, allowing it to process these minerals more efficiently and at a lower cost than its competitors. This investment has not only secured China's position as the leading producer, but has also given it control over the entire supply chain, from mining to final product manufacturing. However, the dominance of rare earth mineral production comes with significant environmental costs. Studies have shown that rare earth mining operations can lead to severe environmental degradation, including soil and water contamination, habitat destruction, and substantial carbon emissions. The process of extracting and refining these minerals often involves the use of toxic chemicals and produces large amounts of waste. China has faced criticism for the environmental impact of its rare earth industry, prompting efforts to improve regulations and clean up production methods. China's strategic advantage in the rare earth sector extends beyond just production capabilities. The country's comprehensive control over the entire supply chain, from mining to processing to manufacturing, gives it unparalleled leverage in the global market. This advantage is difficult for other countries to replicate quickly, as it requires not only significant financial investment, but also years of expertise and infrastructure development. The implications of China's rare earth dominance are far-reaching, affecting various industries and national security concerns. As we look at specific sectors impacted by this situation, it becomes clear that China's control over these critical resources has the potential to reshape global trade dynamics and technological development. The reliance on Chinese rare earth minerals has become a pressing issue for many countries, particularly in industries such as electronics, renewable energy, and defense technology. As we shift our focus to the defense sector, a startling question emerges. Could China's control over rare earth minerals ground America's most advanced fighter jets? The F-35 program, once hailed as the cornerstone of US air superiority, now faces an unexpected threat from an unlikely source. The US military's reliance on rare earth minerals is extensive, with these elements playing crucial roles in various defense technologies. From guided missile systems to night vision equipment, rare earth minerals are essential components in many of the advanced weapons and tools that give the US military its technological edge. The F-35 fighter jet program serves as a prime example of this dependency. This advanced aircraft, designed to be the backbone of US air power for decades to come, requires significant amounts of rare earth minerals in its construction and operation. The program's vulnerability to supply chain disruptions has been highlighted in a recently declassified Pentagon study. The study revealed that the F-35 program has already experienced issues with spare parts availability and maintenance. These problems could be significantly worsened by further restrictions on critical minerals. The report noted instances where planned aircraft were not available due to incomplete repairs, a situation that could become more common if access to necessary materials is limited. China's export restrictions on critical minerals could have severe consequences for F-35 production. Without a steady supply of these materials, manufacturing delays are likely, potentially slowing down the delivery of new aircraft and the maintenance of existing ones. This could lead to a reduction in the overall number of operational F-35s, impacting the US military's readiness and capabilities. The vulnerabilities exposed in the F-35 program are not unique. Other defense technologies that rely on rare earth minerals could face similar challenges. Advanced radar systems, satellite communications, and precision-guided munitions all depend on these critical resources. A shortage of these materials could hinder the development and deployment of new technologies, potentially eroding the US military's technological advantage. Recognizing these risks, the Pentagon has been working to secure alternative supplies of critical minerals. However, these efforts face significant challenges. The complexity of rare earth mining and processing, combined with the lack of existing infrastructure in the US, makes it difficult to quickly establish new supply chains. China's decades of investment in this sector have given it a significant head start that is not easily overcome. The short-term implications for US military readiness are concerning. Production delays and increased costs could limit the availability of critical equipment and weapons systems. This could potentially impact the military's ability to respond to global threats and maintain its current level of operational readiness. In the long term, the situation could have even more profound effects. If the US is unable to secure reliable sources of critical minerals, it may need to reassess its defense strategies and technologies. This could lead to a shift in military planning and potentially alter the balance of global military power. As we consider these implications for the defense sector, it's important to note that the impact of rare earth mineral restrictions extends far beyond military applications. The civilian technology sector, which relies heavily on these same materials, is also likely to feel the effects of these trade tensions. From smartphones to electric vehicles, many everyday technologies depend on the same critical minerals that are essential for defense applications. The smartphone in your pocket might seem worlds apart from advanced military technology, but they share a surprising connection. What if the same trade restrictions impacting fighter jets could make your next phone upgrade significantly more expensive? Critical minerals like gallium and germanium play a vital role in consumer electronics. These elements are essential components in semiconductors, LEDs, and fiber optic systems. They enable the high-speed data transmission and processing capabilities we've come to expect from our devices. Without a steady supply of these minerals, the production of smartphones, computers, and TVs could face significant disruptions. The potential price increases for consumer electronics are a growing concern. As manufacturers struggle to secure these critical minerals, production costs are likely to rise. These increased costs will likely be passed on to consumers, potentially making our favorite gadgets more expensive. Industry analysts predict that the prices of smartphones, laptops, and other electronic devices could increase by 10 to 20% if the current trade tensions persist. Major tech companies are responding to these restrictions with urgency. Many are actively seeking alternative suppliers outside of China to ensure a stable supply chain. For example, some companies are exploring partnerships with rare earth mineral producers in Australia and Canada. Others are investing in recycling technologies to recover these valuable materials from old electronics. The challenges in replicating China's supply chain efficiency are significant. China has spent decades developing its rare earth mineral industry, creating a robust infrastructure for mining, processing, and manufacturing. Other countries lack this established ecosystem, making it difficult to quickly ramp up production to meet global demand. This efficiency gap could lead to production delays and increased costs for tech companies trying to diversify their supply chains. The impact on innovation in the tech sector could be substantial. Many cutting-edge technologies rely on these critical minerals. Restrictions on their supply could slow the development of new products and features. For instance, advancements in 5G technology, which requires gallium-based semiconductors, might face setbacks. Similarly, improvements in display technology for smartphones and TVs could be delayed due to shortages of essential materials. Potential delays in product launches and upgrades are a growing concern for both companies and consumers. The tech industry operates on tight production schedules, with new models and updates released regularly. Supply chain disruptions could throw these schedules into disarray. Consumers might have to wait longer for new smartphone models or software updates that require new hardware components. The ripple effects of these trade tensions extend far beyond individual gadgets. The global electronics industry is deeply interconnected, with components and materials flowing across borders. Disruptions in one area can quickly spread, affecting multiple sectors and economies. As we consider these implications for consumer electronics, it's clear that the impact of rare earth mineral restrictions reaches far beyond military applications, potentially reshaping the technological landscape we interact with daily. The interconnectedness of US-China trade relations forms the backbone of the global economy. These two economic giants are deeply intertwined, with their trade interactions influencing markets worldwide. The ongoing tensions between the US and China have far-reaching consequences that extend beyond their borders, affecting global stock markets, currencies, and manufacturing patterns. Global stock markets have shown significant volatility in response to the trade tensions. Announcements of new tariffs or export restrictions often lead to immediate drops in stock prices across major exchanges. Investors remain cautious, reacting swiftly to any news that might impact the economic relationship between the US and China. This uncertainty has led to periods of instability in markets from New York to Tokyo. The impact on currencies, particularly the US dollar and Chinese yuan, has been notable. As trade tensions escalate, the value of these currencies fluctuates, affecting international trade and investment. The Chinese yuan has faced pressure, with concerns about devaluation as a potential tool in the trade dispute. Meanwhile, the US dollar's status as the world's reserve currency could be challenged if the conflict prompts countries to seek alternatives for international transactions. The trade tensions are reshaping global manufacturing patterns. Many companies are considering relocating their production facilities to avoid tariffs and secure their supply chains. Countries in Southeast Asia, such as Vietnam and Thailand, are emerging as alternative manufacturing hubs. This shift could lead to significant changes in global trade flows and economic relationships. Some countries might benefit from the US-China trade tensions. Nations with strong manufacturing capabilities could see increased investment as companies look to diversify their production bases. Additionally, countries that can provide alternative sources for critical minerals and other resources may find new opportunities in the global market. However, the risk of a global economic slowdown looms large. The Federal Reserve Bank of New York estimated that tariffs have added an annual expense of approximately $831 to each American household. This increased cost burden on consumers could lead to reduced spending and economic growth. The ripple effects of slowing growth in the world's two largest economies could spread, potentially triggering a global recession. The current situation is also fostering the formation of new economic alliances. China and Russia, for example, are deepening their financial and trade ties. This growing partnership aims to reduce their exposure to US economic influence and potentially challenge the dollar's dominance in international finance. Other countries may also seek to form new economic blocs to protect their interests in an increasingly uncertain global trade environment. As these global economic implications unfold, the need for diplomatic solutions becomes increasingly apparent. The complex web of international trade relationships highlights the importance of finding a resolution to the US-China trade dispute. Negotiations and diplomatic efforts will be crucial in addressing the concerns of both nations while minimizing the negative impacts on the global economy. The path forward requires careful consideration of the interconnected nature of global trade and the potential long-term consequences of prolonged economic tensions. As we look towards potential diplomatic solutions, it's clear that the stakes are high, not just for the US and China, but for the entire global economic system. While economic tremors shake the world, behind closed doors, a different story unfolds. What if the key to resolving the US-China trade dispute lies not in tariffs or technology, but in an overlooked aspect of international relations? The current diplomatic channels between the US and China remain open, but strained. High-level meetings between officials from both countries have taken place in recent months, aiming to ease tensions and find common ground. However, these meetings have yielded limited results, with both sides maintaining their positions on key issues. The World Trade Organization, WTO, plays a crucial role in mediating trade disputes between the US and China. As a neutral arbiter, the WTO provides a platform for both countries to address their grievances and seek resolution. However, the effectiveness of the WTO in this situation is being challenged. Some US politicians are calling for a reconsideration of China's WTO membership, which could further complicate negotiations and increase tensions. Several scenarios for resolving the trade dispute have been proposed by experts. One potential path involves gradual tariff reductions coupled with addressing intellectual property concerns. Another scenario suggests a more comprehensive agreement that covers a wider range of economic issues. However, reaching a mutually beneficial agreement faces significant challenges. The impact of domestic politics on negotiations cannot be underestimated. Leaders in both the US and China face pressure from their respective populations to maintain a strong stance against the other. This domestic pressure complicates efforts to find middle ground and may lead to further escalation of tensions if not carefully managed. Despite these challenges, there is still potential for a new trade deal between the US and China. However, the success of such an agreement hinges on both sides' willingness to compromise on key issues. This includes not only tariffs, but also technology transfers and market access. The current environment suggests that achieving such a compromise may be challenging, but not impossible. As negotiations continue, both countries are also developing long-term strategies to navigate this new economic landscape. The US is focusing on strengthening domestic industries and diversifying its supply chains to reduce reliance on Chinese imports. China, on the other hand, is accelerating its efforts to achieve technological self-sufficiency and expand its economic influence globally. The path forward in US-China trade relations remains uncertain. While diplomatic efforts continue, the complexity of the issues at hand and the high stakes involved make quick resolution unlikely. Both countries will need to balance their national interests with the need for global economic stability as they chart their course forward. As we consider the long-term strategies of both nations, it becomes clear that the outcome of these negotiations will have far-reaching consequences. The decisions made in the coming months and years will not only shape the economic relationship between the US and China, but also influence the global balance of power in the technological age. As trade tensions simmer, a silent revolution is unfolding in labs and research centers across the US and China. The race for technological supremacy is reshaping industries, economies, and the very future of innovation. But what happens when two superpowers decide they can no longer share the same digital ecosystem? The concept of technological decoupling is gaining traction as both the US and China seek to reduce their reliance on each other's technologies. This separation could lead to a fragmented global tech landscape with two distinct technological spheres emerging. China is investing heavily in its domestic semiconductor industry, aiming to achieve self-sufficiency in critical technologies. This push comes in response to US sanctions that have limited China's access to advanced chips and manufacturing equipment. The US, for its part, is implementing extensive tariffs on Chinese imports as part of a strategy to protect its industries and reduce dependence on Chinese technology. These tariffs have reached up to 100% on some products, signaling a strong commitment to reshaping the technological playing field. The US is also investing in its own technological capabilities, focusing on areas like artificial intelligence, quantum computing, and advanced manufacturing. China's recent export restrictions on critical minerals such as gallium and germanium are part of its broader strategy to protect national security and maintain dominance in key industries. These minerals are essential for many high-tech applications, and China's control over their supply gives it significant leverage in the global market. The competition between the US and China extends beyond traditional technologies. Artificial intelligence and quantum computing have become key battlegrounds in this tech race. China has made significant advancements in AI, with some experts noting that the US is currently trailing in this field. Former Google CEO Eric Schmidt has expressed concern about the US falling behind, stating, "When you write the successor to your book, you're going to add a chapter of how we screwed up in this area." The global implications of this technological competition are far-reaching. A potential tech Cold War could lead to incompatible standards, separate supply chains, and divergent innovation paths. This could force other countries to choose sides, potentially limiting their access to certain technologies and markets. For other countries, this situation presents both challenges and opportunities. They may need to navigate carefully between the two tech giants, balancing access to technologies and markets. Some nations may find opportunities to develop their own technological capabilities, filling gaps created by the US-China decoupling. Despite the growing tensions, there is still potential for collaboration in certain tech sectors. Companies like Tesla continue to engage with Chinese manufacturers, indicating a complex interdependence that persists despite rising tensions. These collaborations suggest that complete technological separation may be challenging and potentially counterproductive for both sides. As we approach the conclusion of our discussion, it's clear that the race for technological supremacy between the US and China is reshaping the global tech landscape. The outcomes of this competition will have profound implications for industries, economies, and international relations in the coming decades. The US-China trade tensions have reshaped global economic dynamics with far-reaching consequences. China's control over critical minerals has given it significant leverage, impacting industries from defense to consumer electronics. The potential for technological decoupling between the two nations raises concerns about a fragmented global tech landscape. Looking ahead, the long-term outcomes of this situation remain uncertain. We may see a shift in global manufacturing hubs, the emergence of new economic alliances, and a race for technological supremacy. The decisions made by both countries in the coming years will likely influence the future of international trade and technological innovation for decades to come. As we consider the future of global trade and technology, one question looms large. Will the world's two largest economies find a way to coexist and cooperate, or are we heading towards a new era of economic and technological division?